Hello everyone, and welcome to this video on evaluating functions involving radicals. So this video will be no different really than a video I've put up in the past on evaluating polynomial functions, linear functions, quadratic functions, and the like. So we're going to see some function notation here, right, where you have your f of x equals g of x equals, and so on. But this time the expressions that give me the output of a function will involve a radical or a root, a square root, cube root, etc. So I just have several examples of that, and should be a pretty simple one today. Okay. My first example, my first function, and I'm asked to find the value of the function. And the function I'm given here is called f, right, named lowercase f, right, f of x equals the square root of 3x plus 7. Alright, so don't forget, when you see this f of x, right, when you see that function notation, equals, and then some expression, just a real quick recap here of this, what this all means. Remember the expression inside the parentheses after the name of the function, right? This letter on the outside of the parentheses, that's the name of the function. The letter inside, is the input, right? It's some value from the domain, right? One of the inputs of the function. And then what it's equal to. So f of x is equal to the output, right? And basically you have an expression here that tells you how the output is calculated. All right, how it is calculated. All right, so here I have, again, f of x equals the square root of 3x plus 7, so my input will be some value for x, right? We'll replace x here, and the output will be f of x, which is calculated this way, right? By taking the square root of 3 times the input, 3 times this x plus 7. All right. So first in part A, I'm asked to find the value of this function f when the input is 3. And again, this number 3 is just going to replace the x up here, right? It's the input, right? So I go through the rules for this function. I go through this equation up here and say f of 3, the value of this function at 3, or the output of f at 3, is equal to the square root of 3 times the x, but that x is 3. Right? So instead of 3 times x, it is 3 times 3. Notice the dot there, so I don't confuse it with 33. Or you can put parentheses around the 3, whatever, to indicate multiplication. And then plus 7. And then we, of course, simplify this radical. The expression inside, you do multiplication before addition, right? 3 times 3 is 9. 9 plus 7 is 16. And again, if you've been watching my videos on radicals, you know by now that when you see this symbol and you have an even root, an even index, right? This is technically an index of 2, right? The square root. What's being asked for is the non-negative square root, right? Your result should not be a negative number. So yes, you might think, oh, hey, isn't this plus or minus 4? Positive or negative 4, because negative 4 squared, right? Negative 4 times negative 4 is also 16. Yes, that's true, but when you see this symbol with an even index, an even root, your result is the non-negative one. Right? So no plus or minus, right? This square root symbol of 16 is just 4. Okay, so the value of f at 3 is equal to 4, right? So as I've said, this after the name of the function, after f, that's the input. And then what's over here is, what f of 3 is equal to, that's the output. And one other refresher, hopefully this rings a bell as well from a previous video on functions I put up. When you state that, the value of f at 3 is 4, this would mean that on the graph of f, on the graph of this function, let's say on the graph of y equals f of x, or the graph of f, they might just say, we would plot the point. We would plot the ordered pair. And remember how ordered pairs go for points, the input first, right? So the x, sometimes referred to as just the x coordinate of 3, comma, and then the output, or the f of x, or the y, or what's f of 3, and that we said was 4, right? So we would plot the point 3, 4 on the xy coordinate plane if we were making a graph of y equals f of x, or y equals the square root of 3x plus 7. And I'll put up a video in the future, not too long after this, where we actually are graphing radical functions, right? Functions with radicals. Wonderful. All right, now sticking with this function here, I have a part B. All right, part B is simply take the same function, all right? It's f of x equals the square root of 3x plus 7 yet again. And what is now the value of f at the input of 7. So I did the same thing as I did with the 3, right? Input 7, and then f of 7 equals the output, and this is telling me over here, this rule is telling me how to calculate the output. So I go square root of 3 times x, right? 3 times x is 7. Again, you can put a little dot for multiplication, or put 7 in parentheses to indicate that it's multiplication and not the number 37. Right? It's 3 times 7. And then we have plus 7 after. Okay. We have the square root. 3 times 7 is 21. Plus 7 is 28. Now 28 is not a nice perfect square, right? 25 is, right? 25 is 5 squared. 36 is 6 squared. So 28, that's between 25 and 36. This is not a perfect square. So the square root of 28 is actually between, 5 and 6, right? Between the square root of 25 and the square root of 36. So we can leave this the way it is, but, in most texts you're going to be asked to also simplify radicals. And I have, again, put up videos if you've been watching. If not, please look up how to simplify a radical, or using the product property to simplify radical expressions. A radical is not considered simplified if there is a perfect nth power where n is the index of the radical. Well, in this case, the index is 2, right? It's a square root. If there's a perfect nth power that's a factor of the radicand, right, the expression underneath, then it's not considered simplified. So you might ask, this is a square root, so I'm looking for perfect squares, right? Powers of, that are powers of 2. So what's a perfect square that goes into 28 evenly? That is a factor of 28, and that would be 4, right? So you can break up 28 into, a perfect square factor, 4, right, which is 2 squared, perfect square, times 7, the non-perfect square factor. And then using our product property, right, both 4 and 7 are non-negative, so we can split it up, break it up into the product of two real numbers, the square root of positive 4 times the square root of positive 7, right, both real. That was the condition I needed for you to be able to use the product property, right, was that it's split up into two real numbers. And what is the square root of 4? Well, that's again the non-negative square root of 4. That's positive 2. So 2 times the square root of 7. Right, and there you go. And if you want to use a calculator, right, double check. Is this indeed the square root of 28? Well, let's see. the square root of 28, as I mentioned, will be between 5 and 6, right? It's 5.29 something like you're seeing, hopefully. And this 2 times the square root of 7 hopefully is the same thing, and it should be if I did everything correctly, and indeed it is. So I'm seeing the value of f at 7 is 2 times the square root of 7 when completely simplified. Wonderful. All right, so that's the end of that. And again, I'll mention what is another way to what else does this mean? This would tell me that the point or the ordered pair with input 7, x value of 7, and output f of 7, or the y value, 2 times the square root of 7, that point, that ordered pair, would be on the graph of f. And I'll just say graph of f this time, right? Or y equals f of x, like I put on the last page. Great. So again, just like any other function, right? Every input, every value in the domain is going to give you only one output, right? 7 input gives me just this one output, 2 times the square root of 7. 3 in the input of 3 gives me just the output of 4. Wonderful. And that was a square root function. I have just one more with a couple parts of a cube root function, right? And you would do the same with any radical function, 4th root, 5th root, 6th root, etc. All right, so this one, my new function, I have find the value of the function. This one is called g. This function, right? The function g of x is, and again, input's called x, and that g of x is equal to the output. All right, and over here is how you calculate the output. Right? You take the cube root of 2 times the input plus 7. All right. So, just like I did with the function f in the last two examples, I'm asked for what's the value of this function g when the input is -4. All right, so let's take a look. So go to the rule. This tells me how to calculate the output when the input is -4, right? I take the cube root of 2 times, and then not just x now. X is being replaced with -4, and then add 7 to that. And again, this is all inside the root, so simplify that first. So this will be the cube root of 2 times -4 is -8. -8 plus 7 is -1. And you don't have to worry about this because this is an odd root, right? Cube root, 5th root, 7th root, right? Odd roots, you can have a negative number inside as the radicand, right? The odd roots of any number, positive or negative, are going to be a real number. It's when you had square root or 4th root, right? It's when you had even roots that you couldn't have a negative radicand, right? Those were not real. The radicand had to be non-negative. So this is okay. It's an odd root of a negative, so the result will be negative, and this is actually one of those perfect cubes, right? What number to the 3rd power would give me -1? Well, that's just -1 again, right? Again, because -1 to the 3rd power would still be -1. Any negative number to an odd power is negative. All right, so I'm getting the value of this function g at input -4, g of -4, the output is -1. Great. All right, and then again to state what I stated the last two parts, the last two pages. Another thing this means is that the point or the ordered pair with input -4, right? X coordinate -4, comma, output g of -4, the output is -1. That point, that would be, I would plot this point on the graph, is on the graph of this function g, right? Or is on the graph of y equals g of x, right? Or just, you can say, on the graph of g, right? So don't forget this. This is important, right? And like I said, a future video very shortly after this, I'll be, actually graphing some of these radical functions. All right. And lastly, all right, very, very short one today. Just a couple quick radical function examples, or inputting a number, getting an output. So part B, same function, g of x. I'm asked what's the value of g at 10, right? Input is 10. All right, so I run through the rule. Well, how do I calculate the output for this function g? And that's this rule here. I take the cube root of 2 times x, but x is now this number 10, and then plus 7. All right, so this is the cube root. 2 times 10 is 20. 20 plus 7 is 27. And again, here I have a nice perfect cube as a radicand. 27 is actually 3 to the third power when you factor it completely. So the cube root of 27 is 3, right? 3 cubed would be 27. All right, so the value of this function g at the input of 10 is 3. All right, and then one more time. Another thing that this means is that the point, right, I would plot the point or plot the ordered pair, input 10, x coordinate equals, and then g of 10 would be the y coordinate of 3, the output. So the ordered pair 10, 3, or the point 10, 3, I would plot that, on the graph, right, is on the graph. And I'll just say the graph of g this time, right? The graph of function g. Wonderful. Okay, so hopefully pretty simple this one today, right? Just like any other polynomial function I've gone over in previous videos. Just pay attention to what's your input, how do I calculate the output. It was as simple as that. All right, as I like to say at the end of these videos too, is do the best you can to try and learn the material on your own before you go looking for help. I find that when people take the time and the effort to learn something on their own, they tend to remember it better and for longer, and are more proud of themselves. So read the material, of course, read through the author's examples, perhaps even try to work out the solutions to some of the author's examples before you see how the author did it, and then, compare your work to the author's and see if you can learn from some mistakes there. Obviously, work on tons of exercises, practice problems. Check the solutions to those if they're made available to you so you can see how you're doing and track your progress. And don't just give up on an exercise or a problem after 1 or 2 attempts. Don't give up so easily. Very often, in mathematics, there are several approaches that'll work for any particular problem. So, I mean, if after several attempts at a problem you're still not getting it, still not making sense to you, maybe you should read through the material again, perhaps even a third time, more slowly, more deliberately. Take good notes, because if you've been working on some problems, chances are you have a better idea as to what the author wants from you, what the author is asking of you. So then you'll know better what to look for, when you read through the second time or the third time. You might catch some things that you didn't catch the first time around. It'll make working on the problems that much easier. But if after that, if after several read-throughs of the material and several attempts at problems, you're still not getting it, well, it is not a sign of weakness whatsoever to go out asking for help, go looking for help. That is what other people are there for. So, ask a teacher, a tutor, a friend, someone in your class who you know knows the material well and is willing to help. Look for supplemental materials online. There's tons of it out there. Look for videos online. There's tons of those too. Videos like this one. And I assure you there's plenty out there better than this one. They're easy to find, I promise you. But just keep at it. Stay persistent. Keep practicing. Don't give up. And I think above all, Believe in yourself, even through your struggles and failures. Have a positive attitude. It's at the times that you fail when you can learn the most from your mistakes. So stick to it. And I know that's easier said than done, but you'd be amazed at the difference a little change in attitude toward a subject can make. A little change in beliefs can make in the learning process. Alright, so stay persistent, keep practicing, stay positive, and don't give up. And I just know you'll get it. Thank you very much for watching.